So the question they want is what is size, what is angle, what is angle DEF. So that is what they want. So angle DEF is this angle over here. So that's the one they want. All right. So before we start, let's just ask ourselves, what do we have? So so that's what we want. So what do we have? We have this angle A over here. And what is angle A? It's part of a quadrilateral. So let's just see, but what kind of quadrilateral is this? So we have this quadrilateral over here. I'm just doing it with different colors. So we have this quadrilateral, which is part of this yellow circle. And you see this yellow circle. So just focus on that first. Then we also have part of the quadrilateral is still this line over here. Not part of the quadrilateral. It's part a separate section of the quadrilateral. So if I just look at the blue quadrilateral and the yellow circle, so it's two ways. So firstly, what I want to do, I want this over here. So there's a red part, C1. So I want C1. Why do I want C1? It's because if I can get C1, then I'm going to use a theorem. I'm just going to draw this. So if you look at this chord or segment, the red segment goes to this angle over here, and it goes to that angle. So just look very carefully. I'm just going to do it with this green also. So take this segment here. It supports both C1 and E, the one that we want. So it supports both C1 and E because both this segment, if you look at it this way, goes to C1. And if you look at it this way, the same segment goes to E. So that's why the same segment supports C1 and E. So we can already say before we start, C1 equals E. That's why I say if I can get C1, then I have E, or DEF to put it better. Let's just write this better. That's angle DEF. So I always work from the back and see what do I need and how can I get to the answer. So C1 equals DEF. So this is C1 over here. So now highlight it. This is C1 where the red dot is. That equals angle DEF. Now we need C1. So let's go back to the blue quadrilateral. Then we have the angle A equals C1. And that equals 96. So write it better. So again, angle A equals C1 equals 96. Why? We use the rule of this rule over here. If you have a circle and you have a quadrilateral inside of it with the outside angle, then this angle here equals that angle over there. So the outside angle equal the opposite inside angle. That's just one of the rules of a quadrilateral. So based on this rule, and I think the rule is called the extended angles of a cyclic quadrilateral. So just based on this rule, we can say this A, 96, equals this C1, which is 96. And there you actually have it, the answer. If C1, if A equals, I'm here now on top. So if A equals C1, and that all equal 96, and here at the bottom we have C1 equals DEF, then DEF equals 96. And the rule for the DEF it just extended, the angles are supported by the same segment. It's right here at the bottom, angles supported by same segment. Very important just to write the reason down, because you usually get a reason for the answer and a reason for the a point for the answer and a point for the reason. So if that were 2 marks, you have to write the reason down. So let me just explain something different also. If you take, I'm just going to wipe this out a bit. So if you need this information, you can just rewind the video. So if you, I'm just going to show another way just to get to this C1. So we said here on top, C1 equals A equals 96. But you also could have said a longer way and said C2 plus A. So this is C2 over here plus A equals 180, because the inside, the opposite angles, again, can just draw quickly. The opposite angles of a quadrilateral is 180. So that X and Y, X plus Y equals 180. If this was A and B, then A plus B is also 180. All right, so what you can do then C2 would have been 180 minus A, and A is 96, and there C2 would have been, what's that answer, 74, is that right? No, 84. Yeah, so that would have been 84. Then, so C2 would have been 84, that answer over there. And then you could have used the straight line, because there you have the 84, which is C2, and C1 would have been this part over here. That's C1. And then you can just use a straight line to determine this here, which would have been 180 minus 84, and that answer would have given you 96. So 180 minus 84, that is 96. So that's just showing you 2 different ways of getting to the answer. Let's look at another example. So here we have a circle, and we have this tangent over here, CE. We have this tangent over here, ABQ. And this ABQ, the green tangent, touches the circle at B. And this point over here, that's the center of the circle. So that's the center. So already, as we talk, let's just see what can we identify. If this is a circle, if this is, sorry, just want to say again, if that point is a center, that means this blue line is the radius. And if it touches B on the green tangent, then it means this angle over here equals 90 degrees. So we can just write separately here, B1 plus B2 plus B3 equals 90. So just park that somewhere. And we already see B1 equals 20, that is given. So then we can say 20 plus B2 plus B3 equals 90. So I'm just writing it down for now. What do we still have? We have this here, this angle D, which is 50. So we have that angle. And yeah, but that's the only stuff. We only have this green. We have this green triangle here as well. Make it a different color. Make it yellow. So we have this yellow triangle. Okay. So what do we want? The question is determine the size of C1. Where is C1? You want to show properly that is C1. Let's just highlight this. That's the angle we want. That's C1. So how do we determine C1? So let's see what do we have. So if you look at that, what do you call it, tangent chord theorem, the tangent chord theorem, if you look at my videos 1, there I explain it in detail. So if you look at that video, the tangent chord theorem, it will say that this C1, so I'm working backwards now again, eh? So C1, let's remove this. So C1 will equal that over there. If we look at the tangent chord theorem, because the blue is the tangent, the yellow is the chord, and that angle, the opposite, is B2. So C1 equals B2. But we haven't got B2. So let's see if we can determine B2. So we need B2 because if we have B2, then we have the answer. But we don't have that. So let's see what else can we do. Well, we can determine B3 because B3 is also part of the tangent chord theorem, because B3 lies between this green tangent and this chord CB, and that extends to this 50 over here. So B3 equals 50. So there we have B3 equals 50. So let's do that. That equals 50. And now if you use this over here, B1 plus B2 plus B3 equals 90, then B2 will be equal, that will equal 20. So there we have B2 equals 20. So C1 equals B2 equals 20. And there we have C1. Because C1 equals, this C1 equals B2, that's a tangent chord theorem, and B2, we worked it out now using this over here. We have B1 is 20, we have B3, we work that out, that's 50, and if we use that, the answer is 20. And just don't forget to show all your workings. This is 90 degrees because it's I think you write it down as the radius are perpendicular to the tangent. So just to summarize for the last time, we needed C1, but we had B1 and we had this D. So the first thing is just to know that C1 equals B2, because that's a tangent chord theorem. And then we use the B3, we calculated that's 50, and that's gave B2 as 20, and that gave the C1 equals to 20. So for this question, we have the circle, we have this quadrilateral over here. We have that one. We have, yeah, so just going to move that again. We have a couple of triangles. So let's just see what we need. So what they give this whole D as 80. So this 80 is D1 plus D2. So this whole angle here equals 80. Then we have this E1 equals 30. And this point, that's the middle point. So that's what they give, center of the circle. And they want B1 and P1. So B1 is this angle over here. And they want P1. Where is P1? Sorry, this is P. And the one is that angle over there. So they want this green angle. So this line over here is not on the middle. The middle is the big black dot. So just keep that in mind. So first step, let's just see, can we determine B1? So let's just draw this quad again. quadrilateral. Then we have this extension. And like the previous example, we have this angle over there, and the opposite angle is this whole angle over here. So we can actually just say A1 equals the whole of D, which is 80 degrees. I think the reason we can just say is the outside angle of a quadrilateral equals the opposite inside angle. All right, so now we have B1, sorry, A1. Not A1, sorry, B1. This is B. A is just the extension of the triangle, of the tangent. So we have the B1. So excuse me, so that I must just write properly, which is B1 equals D equals 80. So B1 is this over there, right? So we have B1, which is one of the answers they want. So now we have to find P1. Where's P1? P1 is that over there. So we can't find it yet. So let's just see what we have. So we do have this 30 over here. We have this 80. So let's see how we can proceed. So what I'm seeing here, I'm going to try to use a green color. Is I'm going to use, just look at this chord, CB. CB extends to that angle E1. Let's just write this down so long, E1. So this green chord extends to E1, and the same green chord extends to D1 as well. So the same CB, the chord extends to D1. So we can actually say then that E1 equals D1. The reasons is two angles supported by the same chord. That's the reason we can give. So now we have that. So let's just want to remove all the greens. Here we go. So I just write the angle D1, that answer will now be 30. So that and the 30 and the D1 is the same, so D1 is 30. So at this stage, I don't know yet how I'm going to get to P1, but I'm just writing everything that is outstanding so that we can get to our answer. Right. And next up, I'm just going to look at this part over here. So this whole angle, that's 80. But this angle is 30 that we worked out already. So that means D2 equals 50. The D2 is that one there, so that is 50. So I'm just gonna put the arrow over here and say that equals 50. Okay, let's see how we can use that 50 now. So if you want to see if this is 50, D2, then we can actually say the C1 that is also 50, because that is supported by, you know, do this by this arc over here, and that arc extends to that C1, which also extends to that D2. So this arc over there, EB, extends to D2 and extends to E1. That's why we can say E1 is 50. So I'm just going to remove the reds of the arcs now. So I'm now going to look at this triangle. Just looking for color to highlight it with this. Just focus on this triangle over here. EDB. So if we look at that triangle, this angle, the whole angle is 90. Why is it 90? Because so there's the middle, the center, and any line that goes through the center, and if you have any angle like that, then that angle will be 90. So if we draw it like that, any angle through the center, then this will be 90. That's why this whole E1 plus E2 is 90. So if E1 plus E2 is 90, then let's just write it down. E1 plus E2 equals 90. Then E2 will be equal to 60. E2 will equal 60. So now we have that because both of that is 90. And now we actually finish. So let me just show you what I mean that we finish. It's going to make some space. If you need this, just rewind the video, please. So I'm going to look now at triangle, this one here, the EDP. So I just took this triangle EDP and I just drew it here on the right hand side. With this one here is actually E2 that we worked out, that was a 60, and the D2 that was 50. And now you can already see P1, which is this here, is just the insides of the triangle, and then that answer will give you 70. And there we have P1 as well. All right, let's see what we have now. So we have the circle, we have this blue tangent over here, we have this middle point, center, then the reflex angle is 298. So the reflex angle is the outside angle. So we can already work out the inside angle, which is this one over here, because that will be 360 minus 298. So the inside will be, what's that, 62. All right, so we have that is 62. Let's just see what else we have. We have this AB equals to BC. So that we have. So already we know A1 equals C1. So A1 is there. Sorry, A1 equals to C2. So just write that down. So already A1 equals C2, and that will be the isosceles triangle. That's if you look at this blue triangle over here. Okay. So let's see what else do we have. So now I'm just going to look at this triangle. Oh, sorry, what they actually want at the end, they want C1, which is this one over here, the angle, and they want angle A2, which is that angle over here. But I'm just used to writing just while I'm busy with the sum, then I'm just writing everything down, what I'm seeing. So let's come back again. Let's look at the green triangle. So if this is 62, and just keep in mind, if we work, this is the center, that means A to the center, let's call the center O. AO, which is this here, will equal OB, because that's the radius, and the radius are always the same. So that means this angle, A1 plus A2, will equal B1. Do we have it? Yes, we can work it out because we have the 62 over here. So if you just take the insides of the triangle, then you have the 180 minus 62 divided by 2, which is 59. So you will have B1 equals 59, and this whole A, which is A1 plus A2, equals 59. So just keep that in mind. This is the whole angle over here, A1 plus A2. Just check again, that 59 plus 62 plus that 59, yes, gives us 180. All right, so what can we do now? Now I'm just looking at anything else that we can use to continue. I'm looking now at this, let's call it, I'm just gonna make it red, this angle over here. So that's angle AOB. So that's the center, part of the center. But then you look at, let's draw this one blue, this angle over here. Both are supported by this arc AB. So you have this arc AB, it supports that angle at the center and that angle at the chord. So if you have something like that, then usually you say, for example, C2 will be half of that angle AOB, and AOB equals 62. So that means C2 will equals 31. All right, so now we have C2, which equals 31. So now, but just look here on top. Here on top, we said A1 equals 62. So that means we can already say this A1, just going to show you over there, that equals 62 as well. Sorry, 31. Because C2 is 31 and A1 equals C2. So C2 is 31. So A1 is also 31. Not 62, 31. So now we have that is 31. We have A1 that is 31. And now we can see if we can continue. But remember, we have this whole angle over here. So this whole angle equals 59. That means we can, and if this A1 equals 31, then this A2 will equal, so I'm going to show you that A2 will equal 59 minus 31, which is 28. So there we have A2, which equals 28 degrees. So now we just need C1, but just keep in mind at the beginning, they gave us this tangent over here and we've never used the tangent. So I'm just seeing, can I use this C1 maybe as that tangent chord theorem? So let's see, C1 is supported by this chord and that chord takes us to what angle? That angle A1. Okay, and A1 we already have, which is 31, and therefore we can say C1 equals 31. Sorry about all the colors, but I always use colors just to make it easy for myself to identify the question. So to show again, we need the C1. We have this chord CD. Sorry, we have the tangent CD, and we have the chord BC, and therefore I'm using the tangent chord theorem to get to A1. Therefore, C1 equals A1. That's a tangent chord theorem and equals the 31. So this is the part 2. So I'm just going to stop here just to keep the video. Don't want to make the video too long. So this was part 2 of Euclidean geometry. Thank you. Bye-bye.